In this presentation, I'm going to go over how to find intervals where we're trying to look for specific values of x with a given probability, or what we're going to actually denote as small p, as you can see right here. And so again, ultimately what we're trying to do is find this value of x given a certain probability. And this type of computation is usually done to determine confidence intervals when you are conducting hypothesis tests. And we'll kind of cover that in week 3 a little bit more. So what I want to do is just sort of jump right into an example, because I think that will help you see ultimately what needs to be done. So in this case, we have a normal probability density function, and it has a mean of 3 and a variance of 0.5. And what we're trying to do is we are trying to find a value of x where the probability is of x, of some value of x, is equal to 0.3. So how do we do that? It's actually not too bad, because Excel gives us a really awesome function which we call norm inverse. And I'm going to show you what that looks like. But before that, I want to kind of show you what it looks like in our little graph here. So basically what we're saying is that we have some probability value in our PDF that at some point, which we call x, that we don't know, there is this probability that we represent under using the area under the curve that we can ultimately use to find this value of x. So let's do that in Excel. So what I've done, I've already gone in here, and you can see I've put in our mean, our variance. I solved for the standard deviation just by taking the square root of the variance, and I put in our value of probability. And using that norm inverse function, which you can see, which I'm going to actually just redo for you, you type in norm INV, and then you put in 3 different values. The first one is x, which is actually our probability, so 0.3. Our second value is our mean, and our third value is our standard deviation. And then what happens is it tells us what that value of x is. So let's go and look back at our graph. So what we found was that x was equal to 2.63, which is kind of about there. And our probability, again, is represented by this area under the curve, where x is less than or equal to 2.63. So let's do another example, and what I'm trying to do is I'm going to show you 4 different examples, and each example shows a different probability interval and how you ultimately have to solve for it. So in this example, we have, again, a mu of 3, a variance of 0.5, but in this case we're trying to solve for the probability of x being greater than x. So how can we do this? And really our ultimate goal is to keep using this norm inverse function in Excel or other spreadsheet software. So what we can do is we can ultimately say that we're solving for a value of x, let's say, is here. And right now we know that we have a probability, which in our case is equal to 0.1, that is represented here. So what we want to try to do is actually put it into a way that we can use the norm inverse function. And to do that, what we're actually going to do is we're going to use the probability that's represented here to solve x using the norm inverse function. And this interval is described using p equals x less than or equal to small x. So what we know is we know that p of x being greater than x is equal to 1 minus p x less than or equal to x. And if we do some algebra and rearrange, essentially what we get is p x being less than or equal to x equal to 1 minus 0.1, which is equal to 0.9. And this is the probability that we're then going to go and plug into this part of our equation for when we go to use Excel. So let's do that. So now that we're in Excel, I'm going to put in our new p-value, which is 0.1. And again, we're going to solve for this x value. I'm sorry, our p-value is 0.9. And we're going to solve for this x value, which again is norm inverse. Again, p-value of 0.9, mean of 3, and a standard deviation 0.707. And we find that our x value is 0.391. So when we go back here, we find that this x value was 3.91. So let's do another example. So in this example, we are trying to find an x value with, again, a mu of 3, a variance of 0.5, but in this case our probability has an interval from 2 to x. And we want to find this value of x. And we know that our probability is equal to 0.7. So in this case, we're trying to find the probability between, or excuse me, the x value between 2 and some value of x where the probability is 0.7. So what I want to do is I want to sort of delete this so that I have a little more space to write. And what we need to do in this case is we have to, again, rewrite the interval so that we can use that norm inverse function. And we know that p or our probability of 2 being between 2 and x is equal to the probability of x being greater than x minus the probability of x being less than 2. Sorry, I meant to say that this would be less than x. So really what we're trying to say is that we know we're just kind of rewriting this into terms that we can actually solve for x with. And then we just, again, do a little bit of algebra because we know what this value is, and we can actually figure out what this value is using another function in Excel, the norm dist function. And by rewriting it, we get p is equal to 0.7, which is that, plus probability of x being less than 2. And so what we're first going to do is when we go into Excel, we're going to solve for this probability, then we're going to add that to this, and then we're going to use our norm inverse function to ultimately solve for what this specific x value is. So let's do that. Okay, we're back in Excel. Again, the first thing we need to do is we need to use the norm distribution function to find that p of x being less than 2. So let's do this. Sorry. So this is norm dist, and in our case we're going to use 2 as our x value. Our mean again is 3. Our standard deviation was the square root of the variance, which is 0.5. And then we're going to return true because we're trying to find the actual value, so the cumulative. And we get our p, the probability of x being less than 2 is 0.0786. So the probability then of x being less than x is equal to 0.7 plus this value. And then what we do to find our x value, again, we use the norm inverse function, where our probability apologize. Again, our mean is 3. Our standard deviation is the square root of 0.5. And it returns an x of 3.54. So now what this is telling us is that at 2, so here I'll draw it up here, to 3.54, it's our interval, and that's where our probability is represented. So let's do one more example and then I'll let you go. So in this last example, again, we have a mu of 3, a variance of 0.5, but now we have a probability where we know the upper bound of that interval, which is 3, and it's equal to 0.2. So similar to what we did in the past, we have to rewrite this. So we kind of expand it out because we can solve ultimately for the probability of this so that we can use the whole probability to solve for our x value. So let me draw that out. So we have px being less than x to 3 is equal to the probability of x being less than 3 minus the probability of x being less than x. Again, we're going to use the norm dist, and we solve for that. We subtract that probability, or excuse me, what we end up doing is do a little bit of moving things around. We get px being less than x is equal to, in our case, we solve for this in Excel and we get 0.5. So 0.5 minus 0.2, which is this probability here. And using the norm inverse function, we go back into Excel, and I'm going to sort of skip that since we've done that a few times already. And we end up finding our x being 2.63. And that ultimately tells us that from 2.63, which is about here, excuse me, it's about here to here, we have that probability represented. So I hope you have a better idea now of how to take given probabilities, and depending on how our interval is described using our in terms of probability, you can actually go in and solve for that x value so that we can see what that interval is. Thanks.